We saw an example of using the design recipe with a union type that happened to be a bunch of numeric intervals. Okay, and so we followed that. And we ended up with this function tax here. I'm going to go and we're going to introduce one more example of a union type and then maybe a more general discussion. But I will sort of mention a couple things here. When I was writing the code before, the lines got kind of long. In particular, I didn't mind this first line, and I could sort of see where the question and the answer are separated. And the second one, the question, yeah, maybe it's a little bit unclear. Maybe I should add some more spaces there. And the third one, trouble with this, or the middle case, turns out my condition was pretty long. Now, we discussed it didn't need to be that long, but if I did want it that way, I would probably go ahead and indent it to make it more readable like that. Make it clear that the question and the answer are different, and just add some white space to help reinforce that. So, okay. Separately, when you were writing this, you may have been writing the code and sort of feeling that just doesn't feel quite right, kind of has some weird smells about it. In particular, gosh, shouldn't we be using at least named constants instead of 38,700 and 9525 and so on? Yeah. If I look at it, I'm actually not quite being parallel here. For the amount of text from the middle tier, I actually wrote 15% times the size of that middle tier. But for the bottom tier, I didn't do that. I just sort of said I did that calculation in my head and just put it down like this magic number. So maybe that's not quite a parallel construction there. And even so, just all these numbers, it's easy to let your eyes blur over and so on. One thing you might have wanted to do is add a local variable. And so we're not going to talk about that yet. We'll come up on that in a little bit. But just as a hint, yes, you can do that. Here's an example that for the third, this last tier, goes ahead and names a couple of variables. It names, this is the size of that middle tier, the difference between those numbers. And then we also talked about what is the excess of the income. Okay. And so we went ahead and named that. And then we had said, oh, now that I named those two local variables, so they apply just inside this region. Then I said, here's my answer. It's 10% times the size of the first tier, 15% times the size of the second tier, and 25% of the excess. And that was a little bit more readable. In fact, when I look at this, that variable name income, that's a better variable name. I've given this a generic name because I inherited it from the template. Really, I'd like to rename that. So you can actually right-click on the program. Well, never mind. We can do a search replace. Have to be careful not to replace too much. But you can search and replace that with ATI with income and replace. And that actually, I think, makes it more readable code. Although made it longer and started to split across lines, I might go ahead and again, and I think I mentioned this before, if you're going to go ahead and call plus and pass plus 3 different things, either put the whole expression on one line or break it into 3 lines. Do not do something where you break it into, hey, I'm calling plus, and the first 2 things are on the same line and the third thing is on its own line. That just sort of can be confusing, can be easy to miss how many. I like this because I can look at it, oh, we're passing 3 things to plus. It's very clear. Okay, so so we'll talk about this let star construct later to introduce variable names, or you can read it and use it if you like. But okay, it may not be in beginning student. We might have to wait a little bit on that. Okay. Here's my new data definition. It turns out when you're filling out taxes, so here's a new interesting, another union type. Dealing with taxes, and yeah, it turns out that how much tax you pay is not actually just a function of how much you make, your income. There are other special situations. In particular, you might have the case that, well, maybe you just haven't filed your taxes yet and you don't know what your income is. Maybe you are Canadian and you're working in the US and there's a reciprocal tax treaty. You need to report to the US government that you worked here and how much money you made, but you don't need to pay taxes on it. The US and Canada says, yeah, if you're paying taxes to Canada's government, you don't need to pay taxes on that same income to us. So we're going to go and say, I'll call it a taxable income entry. It's the sort of thing you might actually enter on a form somewhere. You might enter, either an amount of income, but you might enter, hey, that you're exempt, or the computer might need to enter false, saying, hey, no taxes have been filed yet for that year. Okay, so yeah, this is a little bit more robust of a richer concept. It's not just numbers, it's still a union type. This is kind of a union type with, again, 2 sentinel values, and then 3 real variants. And I could go ahead and do this. This is one way I could go ahead and write this example. Is there another way I could go ahead and define this new type, a taxable income entry? So again, this is data definition. And be aware, I'm using the terms taxable income. That's what we had before. That was purely a number. And then this is a taxable income entry. Slightly different concepts, slightly different names. Related, but... Okay, so I could go ahead and do, say this is the data definition. Part of me is like, wait a minute, I already have taxable income, and there are places where I still want to talk about just the taxable income. I think a better data definition would be to say a taxable income entry is either exempt or false or a taxable income. And that's now, so it's interesting, we might have a union type with 5 branches, or we might have a union type with 3 branches, but one of the branches is actually a whole nother union data type. Which is better? Which is more appropriate? I think the second one feels better. Okay, we can go ahead, we can take the design recipe and apply it in either way. If we apply it here, we'll end up getting functions that have a con with 5 branches. What will we get here? We're going to get and we'll do this in a second, we'll get a template that has 3 branches, but what is it going to do inside the body of that 3rd branch where you have taxable income? It's probably going to call a different helper function that just handles taxable incomes. And that's separate from the whole idea of, hey, we need to handle a taxable income entry. And that's good design. You take a big problem and pass it off to a helper that does a chunk of the work, but definitely less. It's definitely easier than the whole task, and definitely helps towards the whole task. So, okay. So you can go either way. I'm going to go ahead and sort of say, hey, this is probably the right data definition if we want to take into account these other things, keep taxable income around. And now we can go ahead and say examples of the data, and we just go ahead and say, oh, well, quote exempt, that's easy, and hash false, and excuse me. And I could go up and just copy paste the examples I already had of these, of taxable incomes. And that's fine. I'll go ahead and just sort of say, I really, in some sense, I've already taken care of that. I'm going to have just one example, something that tests all the various variants of taxable incomes. That's a separate problem that we've already done, that we've just finished. So, okay. So here are some examples of let's go ahead and do that there. What would a template look like? A function for a taxable income entry. You hand it one particular taxable income entry, and now we can ask, hey, so I haven't written this from scratch, but we've talked about these things. Hey, am I a symbol? If I am, I know that that's good enough. Am I false? So false question mark is built into the language. I could use that. If not, Boolean question mark is enough. I could reason about that. And then I'll simply say something like a real number. And that's enough. If I reach that, I know that I have a taxable income entry. Okay. So, and now if I were writing a function about how much money to pay, I might have a function that takes a taxable income entry, and if you're exempt, you pay 0. If you're false, gosh, maybe you have to pay maybe the time's already passed for that tax year, you have to pay a penalty, and just sort of say, gosh, you better pay something, and then file it, and we'll refund the difference later. So, I might have some code there that corresponds to actual US tax code. And then what would I do here? I probably would not fill this up with code that you might say, oh, well, this dot 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 would be, well, it's handling a variant type. It will be a cond with 3 branches. Rather than put a cond inside a cond, I could, but I think it makes more sense to say, hey, call a helper function, do the test for that helper function by itself, like we did, and then that is a better solution overall. So, so that's how I would go ahead and probably write this, and I can get this all out of a big block comment. Where did that go? And that. Okay. So yeah, I can actually get that going there. Okay. And then, again, this is what we just talked about. Rather than have 5 branches, it's maybe 3 branches, but one of the branches refers to a whole nother data type. That's the right way to decompose problem. Notice it's actually a way of decomposing the data, our data types. What follows from that is the fact that I should be calling a helper function in a certain place. So the structure of my code is following the structure of the data.